Let's have a look at the next example where we are to find the equation of the locus of all the points that are equidistant from the point S, which is 4, 3, and the line, and it's given as, it's just named D, and its equation is y equals -3. Find the equation of the set of points, and remember, we're going to start off our solution. Our set of points are going to be x and y points, and hence our equation will be in terms of x and y. These points must be equidistant, so I'm thinking we'll talk the distance formula. From the point 4, 3 and the line y equals -3. Let's again have a go at seeing if we can get some sense from a diagram. So the point 4, 3 is here, and the line y equals -3 is down here. And I've got to get a point that's equidistant. So I think we can see that there's a point that's equidistant between S, they call this S, which was 4, 3, and the line y equals -3. So nice equidistant, halfway between. Now, I'm not sure if you can see some other points that may be equidistant. So here, maybe that and that, although maybe it should have been over a little bit further. If I came right across, well, that's only 4 units and that's 6 units. So I'd have to go maybe down over a bit more, maybe more at, whoa, that's not looking so good. Probably at this stage you would give up and go, well, I don't know where I'm going here, and not spend any more time on the graph. However, there's one thing I've really got to tell you about this, is that after the next exercise you will recognise this description and you will write your equation straight down, because this is the geometrical description of a parabola. And so I actually know that the set of points looks a little more like this, because that is the definition, like I said, for a parabola. And I would assume that you've probably never heard of parabola described as the set of points which are equidistant from a given point and a line. But that is exactly the locus description and the formal description for this parabolic shape. And once we've established that, and we will find our equation is in the form of a parabola, so you're expecting a y equals x squared something going on. Any question that asks you to do it using the algebraic method, of course, yes, you'll do it that way. But once you have, like I said, learnt the details about a parabola, these additional details like the name for this point and the name for this line, you'll be able to write the equation straight down for, you'll be able to write its equation without having to do all the algebraic steps. But for now, we need to go through the process. I'm going to pause the video and write it up and come back and talk about it. Okay, so you can see I've got the complete solution there, but let me start here at the beginning. So we know that we, I should write let there. Let P equal xy. So this is our point and it's representing our infinite set of points. And S, they've said P has to be equidistant from S, which is the point 4, 3, and to this line y equals 3. So I've actually tried to write that the distance from P to S has to equal the distance, I guess I should put a little d there, the distance from P to the line. Now, anytime we're talking distance, because we don't want a square root in our equation, we will square both sides. So I'm squaring the distance between P and S, all squared, will have to be the distance from P to the line, all squared. Now, let's introduce the algebra now. The distance from P to S is, well, this is my, I think I actually called these x2, y2, x1, y1. So x2 minus x1, all in the bracket squared, y2 minus y1, all in the bracket squared, is equal to y plus 3. Now you're probably wondering, where does that come from? Where does this y plus 3 come from? If you think about my point P, the distance from P to the line obviously is this distance. Now, what we know is that much is 3 units, because we were told the line existed at y is minus 3. And we know that this distance is actually called y, because I'm calling the point, this is the point, x units horizontally and y units vertically. So that distance there together is called y plus 3. So I want that distance, y plus 3, to be squared. Now, I didn't use the distance formula to get that y plus 3. I just used my understanding of the situation to get the y plus 3. So there was never a square root in it. It was just the distance what I could see was called y plus 3. So I've expanded out those brackets and got x squareds and y squared again, and you're probably thinking, well, this is going to be a circle, not a parabola. But as you see, when we start to take, well, I've separated x terms on the left-hand side, y terms on the right, and when we take y squared over to the other side, they cancel one another out. So that and that is gone. So I've left x squared minus 8x here. 16 and 9 are 25. And when you take 25 to the other side and subtract it, 9 subtract 25 is minus 16. Now I was looking at that and going x squared minus 8x equals 12y minus 16. I probably could have stopped there and written it in with y as the subject. The moment I've got a y is equal to some x squareds, I know I've got a parabola. I went on and I completed the square just to get a sense of where the vertex would be. Now, written in this format, it's really nicely in the format x squared is 4ay. It's really nice. The whole emphasis for many of the exercises in this chapter is based on this understanding as another way of writing the equation for a parabola in the format x squared is 4ay. And you'll see the significance of this a in terms of the point and the line as we move into, I was saying, you're going to learn some more features about the parabola. You'll learn about its significance. So that is often where you would stop. Otherwise, if you want to just be convinced that it really is a parabola back in the format y is something x squared, well, you can write it like this, because if we expanded that bracket out again and divided through by 1/12, then we're getting our ax squared plus bx plus c. So this is the formal geometric description or definition for something that we've known as a parabola. And I'll stop the video now.